last drawing of the week, slotted spacer. So on this one, I'm just going to help you get started and show you how to do the sketch, and then you can do the rest on your own because I think you've learned enough. It's similar to the guide block that we just did. Actually, after the sketch, it's easier than the guide block. So we create a document, and it's period. I'm going to put the number signal because one or two, depending on who you are. Then your first name and your last name. And first name. And then this is called the slotted spacer. Okay, so it's going to be P1 last first slot spacer or P2 last first slot spacer. A couple of you put the first name, last name. I want last name, first name. After this week, I'm going to start taking points off if you don't do this right because it costs me time. Time's money. In your currency, times points. All right. Now, this is metric. So let's change our units to millimeters. Can be centimeters, but in this particular case, it's millimeters. We don't worry about the rest because we're not going to weigh it or anything. Now you're going to have to. I've given you a document. You'll get the document up and you'll compare these numbers. For the sake of time, I'm not going to show those to you right now. You can have that up and look while you're reading this, while you're watching the video. So we're going to go in the front plane and we draw a shape that looks like this. Lined up there. Okay, the bottom of this is 56. Now notice this is 90 is quite a bit bigger than 56. So when I put in 56, it's going to kind of proportion everything else to that 56. And it tries to keep a similar shape, which is actually good. I've been in software that didn't do that and makes it more difficult. So this is 13. And we have a couple angles here. This is angle is 135. So we know how to do that. We just click this line. It's 135. Now that 7 is the depth of the cut. It's not how long anything is. Now on this diagram that you have, this is the European system of things. American, we put the top view on the top. For some reason, the top view is on the bottom here, but they call it first angle projection, I think. So I don't quite understand it, but it is the top view on the bottom. And you can see that line to the 7 is a dotted line. It's a hidden line. Now the top is 36. Now, it shows out here that the angle from here to here is 150. Well, we know when you have, let me show you something out here. When you have two intersecting lines, one like this and one like this. There we go. This is a geometry lesson. These, what they call vertical angles, the angles across from each other are equal. This angle equals that angle, and this angle equals that angle. Because this plus this adds up to 180, and this plus this adds up to 180. Anyway, the angles across from each other are equal. So that's important to know in this, because I don't want this line anymore. that means that this angle here is 150. So there, you'll get an extra point on your SAT test because you know the vertical angles are equal now. This is why you go to math class, to learn how to apply it in real life situations. Now, the last thing is we don't know how this, we have to assume. Let me show you something. If I grab this now to move it, see, it's not, we don't like that. It's not holding together. That's because it doesn't know how long this line is right there. And there's nothing on there, so we have to assume it's the same as this line. So we're going to click that line and this line. And we've done this before. We're going to tell it to be equal. These are called constraints. When you constrain something, you limit its ability to move. We put our dog on a chain to constrain it to the front porch when they're outside so it doesn't run out to their yard. Now if I grab this line, I can move the thing. That's how we've moved around our parts in a document. But if it's fully constrained. So that's from there, you can do the rest of this pretty easily. I just wanted to show you that much.